Okay, 3.2, there was some question marks on 28. A ball is thrown into the air from the top of a building. Its height in meters from the ground is given by this. And notice it's that, so it has to be in meters that we talked about. From what height was the ball thrown? So the ball was thrown at presumably times 0. So if I put 0 in here, we get 8 as the y-intercept, or 8 meters high, because it was thrown at time t equals 0. So I put 0 in for the t's. How high does it get? Well, this is a parabola, and its peak is going to be at minus b over 2a. So minus 24 over 2 times that, it would be minus 9.8. That's what we'd use for t. And the minuses cancel. And getting my calculator here, we put in, where's my calculator? Here it is. We put in 24 divided by 9.8. 24 divided by 9.8. So at time 2.4489 seconds, it will be at the top. Now, we can put that into the equation if I type it in, and the equation is negative 4.9 x squared plus 24x plus 8, and I can go second, or let's zoom 6 to graph it. There it goes up, there it comes down. You can see it starts at 8 high, but we shall find out the peak here. But first, let's find out the value at 2.4489 seconds, and it says it's at 37.3878, if I round off, meters high. Now let's go a second, calculate the maximum, the other way to do it, and that maximum, it's going up and coming down, is somewhere between 0 and 5, so I'm going to go between 0 and 5, and maybe it's about 2 for my guess, and no, it says 2.4489. And it says it's up at 37.838775, what we had before. Okay? When does it hit the ground? Right there. Second, calculate the 0 that's between 3 and 7. 3, enter, 7, enter, and let's say it's about 5. And it says no, 5.211 seconds. 5.211. Or we could set this minus 4.9 t squared plus 24t plus 8 equal to 0, and use the quadratic formula. And I happen to have that in my calculator. I'll write it out here. So it's the opposite of b, so negative 24 plus or minus the square root of 24 squared minus 4 times a minus, so that makes plus, times 4.9 times 8, all over 2 times a, which is negative 9.8. But using the calculator, calculate the quadratic formula with a as negative 4.9, b as 24, and c as 8. It says it's at the ground, before it was thrown. Well, that's obviously not what we want, so it must be at 5.211 seconds. And just to look at the graph again, that minus was if it were followed back from where it was thrown at negative time, it would have been at 0, and at 5.211 it was at 0. So, and I've shown you several ways to answer this problem.